Before we get into actual problems involving inclined planes, it'll be a good idea to review some of the fundamentals about triangles and angles. First, we have to define sine and cosine. Most people from high school remember that sine and cosine are the ratios of the sides. They frequently use the expression SOH-CAH-TOA. For sine, they mean opposite over hypotenuse. For cosine, they say CA or adjacent over hypotenuse. What we're talking about is the sides relative to an angle. So if this is my triangle here, and I draw this angle x, my opposite side is going to be the side farthest away from it. My adjacent side is going to be the flat side touching the angle. And my hypotenuse is always my slanted side. So if I had a triangle here, and my sides were 3, 4, and 5, and I had this angle x, the sine of my angle would simply be my opposite side over my hypotenuse, or in this case, the sine of angle x would be equal to 3 over 5. Likewise, the cosine of angle x would simply be equal to my adjacent side, which is 4, over my hypotenuse, which is 5. You're also going to have to be familiar with a couple special right triangles. For any right triangle, you can use the Pythagorean theorem. That is, a squared plus b squared equals c squared. For any right triangle, it really doesn't matter what side a and b are, as long as you make the long slanted side your c. Beyond that, there's also triangles you have to memorize known as the 30, 60, 90 triangle and the 45, 45, 90 triangle. On the 30, 60, 90 triangle, there's a special ratio of sides. The side opposite the 30 degrees, that's going to be your shortest side. We'll call that x. The hypotenuse on that triangle is going to be twice as big as your shortest side, or 2x. And the remaining side is simply going to be the shortest side times the square root of 3. Incidentally, you should remember the square root of 3 is roughly equal to 1.7. So, if there was a problem that gave you a triangle, and it mentioned the angle was 30 degrees, and then it told you the opposing side was 10, you would know the hypotenuse is going to be 20, and the remaining side is going to be 10 times 1.7, or approximately 17. You should also memorize the 45, 45, 90 triangle. The 45, 45, 90 triangle has two angles that are 45 degrees, and the remaining angle is 90 degrees. Because two of the angles are the same, the two sides are also the same. So the ratio of the sides is x, the other side is also x, and your hypotenuse is x root 2. This triangle is not nearly as common as the 30, 60, 90, but it does appear on some exams. When you have an object sliding down an inclined plane, there are going to be a couple of forces at work. The first force is going to be gravity. The equation we use for gravity is mg. That's the mass of the object times the acceleration we get from gravity, which is always 10. The second force is going to be friction, and friction is going to act in the opposite direction of movement. The equation for friction is simply mg times the frictional coefficient. And the frictional coefficient is simply a measurement of how sticky or smooth the surface is. When you have an object sliding down an inclined plane, both of these forces get modified. Gravity gets reduced by the sine of the angle. So the force sliding down is now going to be mg sine whatever the angle happens to be. Friction is going to be your mass times your gravity times the frictional coefficient times the cosine of that same angle. These equations might look scary, but remember, in terms of sine and cosine, you're not expected to memorize very much. The MCAT will either outright give you what the sine of the angle is, or it will ask you to remember one of the special right triangles with very simple sides. So let's try a sample MCAT problem. We have this hill that's 20 meters high, and the distance down the hill is 40 meters. If I turn this into a right triangle, what you should recognize is that my short side is half the size of my long side, which means they're setting me up for a 30, 60, 90 triangle where the ratio of my sides is x, 2x, and x root 3. Now we want to figure out how long the ball is going to take to slide down the hill. Our acceleration normally with a falling object is going to be 10. But in this case, the acceleration from gravity gets modified due to the inclined plane by the sine of the angle. And the sine is the opposite over the hypotenuse. So if our angle x is right here, my opposite side is 20, my hypotenuse is 40, so the sine is going to be 20 over 40, which simplifies down to 1/2. Now my acceleration from gravity is the 10 from gravity I started with times the 1/2 I got from the sine of the angle. Or my acceleration from gravity is simply 5. Now I have my equation. So x is equal to 1/2 at squared. Or the distance we traveled down the hill, that's my 40. That's equal to 1/2 times my new acceleration, which is 5, times my time squared. Do some algebra and we get 16 is equal to time squared, or t is equal to 4. Let's try one more. This time we don't have information about the length of the sides, but we do know we have a 30-degree angle, which means we're dealing with a 30, 60, 90 triangle. So right away I should fill in the ratio of my sides. I know my shortest side opposite the 30 is going to be x. My hypotenuse is 2x, and my medium side is going to be x root 3. Then they tell me I have this object that's going to slide down, and that object weighs 100 kilograms. The question is asking about friction, and my equation for friction on an inclined plane is my mass times my gravity times the frictional coefficient times the cosine of the angle. As always, my cosine is the adjacent side over my hypotenuse. In this case, my adjacent side is x root 3, and my hypotenuse is 2x. I know my mass, I know my gravity. They also tell me my frictional coefficient. So I can write out the force of friction as my mass of 100 times gravity times my frictional coefficient of 0.5 times the cosine of my angle, which is x root 3 over 2x. My x's cancel out, and I can rewrite my question as 500 times 1.7 divided by 2, which is roughly 500 times 0.85, which is going to be a little bit more than 400. Remember, the MCAT is not an arithmetic test. So if you find yourself doing long multiplication or long division, that's usually a mistake. Most of the time, your answers will be far enough apart that you can easily estimate once you get close.